Hi, this is Mr. Kanaar from Saginaw High, here with another episode of the classwork we did during 7.4, well, chapter 7.4 here. I just kind of want to run through the problems real quick. So the problems that we did was on page 442. We were doing 8 through 23, all of them. And basically, in this particular section, we're looking at exponents that have the same bases that are in fractions. So you have, like on number 1 here, you have 5 and 5 are both in the numerator and denominator. What do you do in that situation? And what we're going to do is we're going to end up subtracting those particular exponents. So I'm here, my homework, number 5. You have 5 to the 8th power divided by 5 to the 2th power. Now I could expand that out and then cross out the 5s and get my answer. That could be one mode of operation. But an easier way is to just subtract the 8 and the 2 and I get 5 to the 6th power. Here's the property that you're going to use on each one of these problems starting out. They get a little bit more complex as we go along. Let's look at number 9. Now number 9 here has a fraction. We haven't got into the radicals yet for our exponents. That'll be in the next chapter, which is, or section I should say, 7.5. And in this one you're going to take 7 over 3 and subtract it by 2, and you're going to get 2 to the 1/3 power, which is the same as me writing the cube root of 2. I wanted to show my fraction work here because a lot of kids have a paranoia of doing fractions in the class. I know when I was in school, especially in middle school, I really didn't understand fractions very well. And then as I got older, I realized they were very simple if you just understood what you had to do. So I have 7 over 3 minus 2. And then I raised 2 over 1, which is the same as 2, and I'm going to multiply it by 1, which happens to be 3 over 3. I look at the denominator for the 7 over 3. I realize it's 3. I want to make the denominators the same, because when I make the denominators the same, then I can just add or subtract the numerators across. And I'm going to get 7 over 3 minus 6 over 3, and I end up getting 1/3. And that's how I got that one. Number 10, pretty easy. We have 3 to the 2nd power over 5 to the 5th power. You subtract, you get 3 to the negative 3rd. Now you could drop that down if you wanted to and go 1 over 3 to the 3rd power. We use that rule, and that would ultimately be 1 over 27 if you went out and did it all the way through. Now in this one, we had stuff that we did in the previous section here where we had to add the exponents together, because on the top we have 5 to the 2nd power times 5 to the 3rd power, so you're going to add 2 and 5, and on the bottom it was the same thing. And this is kind of a nice, almost like a proof here to show you why 5 to the 0 is going to equal 1. You can see that 5 to the 5th power divided by 5 to the 5th power, if you divided those two out regularly, you would get 1. And so you're going to have 5 to the 0 power. It asks you to keep it in an exponent form, I believe, in the problems there. They wanted to make sure that you kept everything in your exponent form. That's why it looks the way that it does. They just wanted the exponent, what the exponent was going to be. That's why we didn't go all the way through with those ones. And then we did 12 through 23, which it says simplify each expression. So once we got here, we had to go all the way through to find it to be to show the expression in its simplest forms. So we have 3 to the 8th over 3 to the 6th, which is going to be 3 to the 8 minus 6th power, which equals 3 squared, which most people probably have memorized by now that it's 9. This one here, we have 9 to the 3/4 power divided by 9 to the 1/4 power. You're going to subtract that out. It is easy. The denominators are the same there. We can just subtract right across the top. You're going to get 2 to the 4th, which equals 9 to the 1/2, which ultimately is the same as me asking what's the square root of 9, and that equals 3. Okay, number 14 here. Same type of problem. D's are the bases. They're the same. So I'm going to say d to the 14 minus 17th power. I'm going to get d to the negative 3, and I'm going to drop down. I'm going to get 1 over d to the 3rd power, and you can see what property we use. Now I accidentally didn't do the problems in chronological order. That's that mess there. I apologize. And then on number 15, I have negative 1 to the negative 4th power. I flip them around. That's our rule that we use. If you have a negative exponent in the denominator, it raises up to the top to the numerator and vice versa. So I'm going to get n4 minus 1, which equals n to the 3rd. And as we go along, the problems do get a little bit more difficult. Here's number 16. On 16, we're going to drop the negative 7, s to the negative 7 down to the bottom, and we're going to raise s to the negative 9 to the top. Now, one thing you want to make sure is don't move the constants, okay? The constants are not part of the negative, only the variables are. I saw some kids with their homework, and they were flipping the 10, and they kept getting 2 on the top when they simplified. You can see I simplified there 1 over 2 now because that's going to be 1/2. You simplify, you know, 5 goes into 10 twice. And we have S9 minus 7, which is S squared over 2 is our final answer. Here's some of the properties I used to solve that particular one. You can see them there. They're also in the book if you look at them. And in this one, I know that I have x to the 11th power, which is going to end up equaling 0, which any base to the 0 power, or x to the 0 power, that's just going to equal 1. And then we have 3 to the 3rd over y to the 1. So I'm going to put 3 to the 1, or I'm sorry, y to the 3rd minus 1. So I'm going to have x to the 0 power, y squared, which equals 1 times y squared. Anything multiplied by 1 equals itself, which is y to the 2nd power. And there's some of the properties that I used out of the book. I want to make sure you guys look at the properties, memorize the properties, because it's going to help you build strategy to solve the problems. Now, in this one, we're going to flip the d's around. You can see that the d to the negative 5th goes down the bottom on the other side, and d to the negative 1. That's the first thing I want to do. And then in this one, I have my fraction work there. I'm going to take 2 over 3 minus 1/6. I want to change the denominator to make it equal 6. So I'm going to multiply the top and bottom by 2. That would be 4 over 6 minus 1 over 6. And that's kind of my work there. You can see that I end up getting c to the 1/2, d to the negative 4th. I'm going to have to drop the negative 4 down. So I get c to the 1/2 divided by d to the 4th. And they're not having you put them in a radical form yet. They want to make sure you keep them in exponential form when you're doing these. And when we get into the next chapter, there's problems for each one. And you can see my fraction work here. I ended up putting in there 2 over 3 minus 1/6. Okay, I multiply 2 over 3 by 1, and I'm going to make that equal 2 over 3 times 2 divided by 2, which is the same as 1. That's why we can do that. We have that identity property in multiplication. Any number multiplied by 1 equals itself. When I ended up expanding that out, you can see 2 times 2 equals 4, 3 times 2 equals 6. Subtract it out, I get 3 over 6, which reduces to 1/2. And that's where I ended up getting that answer from. Now I'm down here on the bottom. Here's some more problems. I'm just going to have you take a look at them. Not going to truly explain through everything. So I'm running out of time. I have 2 minutes left. I only am allowed 10 minutes on YouTube to kind of explain these problems. Let me shoot you an overview in case you're trying to kind of look. And then let me move it over here to the other page too. You can freeze or pause, I should say, the video to kind of look at what I did if you're lost or confused. And then the last couple problems got a little messy as we went along. Not too difficult though. You just have to make sure that you apply your rules. So 21 here, you can see how I went through and kind of simplified everything. And I ended up expanding that 3 times 3 times 3, which equals 27. And then 22, same thing, top and bottom. I see the z's cancel each other out there. It's going to be z to the 0, which equals 1. And I ultimately get x to the 4th over y to the 1/2. Show my fraction work there. In case you guys get lost on the fractions, just want to make sure you know how I did that. And the last one wasn't too hard. You just had to go through step by step, making sure you remember that you use your property. Right there's the property you wanted to use for most of each one of those variables. And you simplify the 12 over 4, and you ultimately get 3b to the 7th, all divided by a to the 6th power, c to the 8th power. And that's the properties that I use. I'll see you guys in class later. Hopefully this helps you out. You guys have a great day.